Section 2.3 deals with the product and quotient rules for derivatives. Up to this point, we've only known the power rule, and the power rule can only be done to a single variable term to a power, with or without a coefficient. So if we've had anything that had parentheses in it or that had multiplication in it, we were forced to distribute first. The product rule and the quotient rule are the things that are going to allow us not to have to do all of that distribution, to just take it as it is and find the derivative from there. So what the product rule states is that the derivative with respect to x of two variable functions, and it's important that you recognize they're two variable functions, because if one of them isn't a variable, then you're dealing with just a coefficient. So two variable functions, to take the derivative, will equal, let's say you have f of x times g of x. It will equal f of x times g prime of x plus g of x times f prime of x. In other words, it is the first function times the derivative of the second function plus the second function times the derivative of the first function. And that's typically how you hear that. First times the derivative of the second plus the second original function times the derivative of the first. You'll hear that sometimes said first d second plus second d first. First d second plus second d first. So most people do better from the word formula rather than the more what do you want to call that? Just the more traditional. Most people learn the words, not the traditional formula. I guess that's what I'm trying to say. Like most people don't do well with the F's and the G's, but if you think about it in words, what it's saying, most people do okay with that. We'll kind of try to look at it both ways though. So for this example, we have h of x equals parentheses 3 minus 2x squared multiplied by parentheses 5 plus 4x. Up to this point, if we wanted to find that derivative, we would have to FOIL or distribute it out and then take the derivative of each term separately. Do you guys understand that? Okay. Well, what the product rule allows you to do is just to skip over the distribution. Sometimes it turns out just to be easier to do it by distributing it anyway. So, you do sometimes get a choice if the directions don't say. Let's see if we can do the product rule to this. We have h prime of x equals. We need to identify our first and our second function. So this is our first function, we'll call him f of x. And this is our second function, we will call him g of x. So first function, second function. And we want to take the first times the derivative of the second, which would be parentheses 3 minus 2x squared multiplied by the derivative of just this parenthesis. What's his derivative? 4. Will it bother anyone if I put it in the front?
No.
I like for my monomials to come in the front. So it's first times the derivative of the second plus the second times the derivative of the first, which is what?
4x.
Not just 4x, but
Negative 4x.
yeah, it's 0 minus 4x. So it's a negative 4x. Is that okay so far? Okay. Now you are not allowed to stop when you have addition and subtraction outside of parentheses. So you have to do that distribution and clean everything up. So at some point, you're going to have to distribute. It's just, do you want the burden in the beginning or in the end? So that gives us 12 minus 8x squared minus 20x minus 16x squared. And that will clean up to what?
Negative
24x squared minus 20x plus 12. And I am sorry to report that it is here in this section that we now make you factor final answers and get least common denominators. So we're going to go ahead and factor out of that a negative, what will come out of there, you guys? Negative 4? Let's take out a negative 4. And that will leave us with positive 6x squared plus 5x minus 3. And then we're really supposed to check to see if that will also factor.
Wait, oh, like the.
The parentheses, you need to factor it as far as you can. Does that factor? You sure?
We're getting caught up.
Here, we'll pause and we'll double check. I don't think it does.
It doesn't.
So we double checked and that's as far as it goes. So that is working the problem using the product rule. Let's look back and just see that we get the same answer if we distribute first and then take the derivative rather than using the product rule. If I distribute first, I get first times first is 15, outer times outer is 12x, inner times inner is negative 10x squared, and last times last is negative 8x cubed. Then we would apply the power rule. We'd have h prime of x equals 0 plus 12 minus 20x minus 24x squared. Isn't that the same thing we got before? And then we could rewrite that in descending powers of our x's and factor out a negative 4. So you'll get the same thing. The question is just which one's more comfortable to you. As we get a little deeper, you'll find that there are some you would never want to distribute out. So it's good to practice with these, even though for now it kind of seems like boiling this out would have been a better bet for us, right? Okay, so we'll do lots of practice on this. For the next example, we want to find the derivative of y equals 3x squared times sine of x. Now this is a problem that you can't do without the product rule. Some things you have alternate methods and some you don't. This one you don't have an alternate method. If you have a variable function multiplied by a trig function, you are going to have to do the product rule or quotient rule with them, okay? There's no way, there's no distribution to be done. So here's what we need to do. We need to visualize it as two separate functions. So we see this is the first function and this is the second function. Does that make sense?
Yes, ma'am.
Okay, so you always let the coefficient go with the first function. Then you simply talk yourself through the formula. First times the derivative of the second, so we have 3x squared times what? Right, so 3x squared times cosine of x, plus the second function, which is sine of x, times the derivative of the first function, which is 6x. And what I usually do is I go ahead and you know that you're going to put your trig functions last, so I kind of just save a little spot in there because you want your trig function to be last. Are you all good so far? Yes? Okay, that's all of the calculus. That's our product rule at work. First times the derivative of the second plus the second times the derivative of the first. And from there, all we need to do is factor it and we'll be finished. So what can I take out of both of these guys? A 3 and an
X.
All right, so if we take a 3x out, we're left with 1x times cosine of x plus 2 times sine of x. And that's our final derivative. That could not have been done if we didn't know how to use the product rule. For our third example, we want to find the derivative of f of x equals 2x cosine of x minus 2 sine of x. First off, there are no parentheses, so there's no distribution that could be done. But there are already how many different terms? Two. So we're going to have to work this. We're going to have to do the derivative of the first term minus the derivative of the second term. But the first term right here is a product. So in order to find the derivative of that first term, I have to use the what? Product rule, yeah. Now if that were just 2 cosine x, I wouldn't have to, but because it's 2x cosine x, I'm going to need the product rule. So we're going to view this as two different functions. We're going to take the derivative of them using the product rule. So for this piece, just right here, we have first times derivative of the second, which is 2x times negative sine of x, plus the second times the derivative of the first, which is just cosine of x times 2. Yeah, the derivative of 2x is 2. All right, that's the product rule. First times derivative of the second plus second times derivative of the first. So we're finished with the first term. Now we need to move on to the second term and take the derivative of just this guy. So the derivative of that guy is minus, and we don't need the product rule because we don't have a variable with the 2. We just have a coefficient of 2. So we just say minus 2 times the derivative of sine, which is cosine. And then we have to clean it all up and combine like terms. Hey, look at that. What happens to these two?
Ooh.
They add to
Console.
0. And then we just have this guy. If we multiply that out, we get negative 2x times the sine of x. And that's our final derivative. We only have a monomial, so we don't have to worry about seeing if we have a common factor. For our fourth example using the product rule, we have y equals the trinomial 2x squared plus 3x minus 5 multiplied by the binomial x plus 1. And rather than distribute that out and then take the derivative of each term separately using the power rule, we're going to use the product rule. So first we need to identify what our two functions are. We'll let the trinomial be the first and the binomial be the second. So yeah, y prime equals the first function times the derivative of the second function. So that is 2x squared plus 3x minus 5 times the derivative of the second function, which is 1. And I usually write the numbers out in front. Plus the second function, which is x plus 1, multiplied by the derivative of the first function, which is 4x plus 3. Any questions so far? Okay, at this point the calculus is done and we just have to clean it up algebraically and get it factored. There's nothing to distribute here. Oh, and by the way, a lot of times calculus students don't know, can I stop or can I not stop? When can I have parentheses and when can I not? And here's the rule. You are not allowed to stop if you have parentheses and you still have an addition or subtraction sign outside of them. So like, if none of this was here, if this were all missing, I could stop and just leave it here. But because of this plus sign right here, in between the parentheses, you are not allowed to stop. You must get rid of all of the parentheses and convert it so that it has no addition or subtraction outside of your parentheses. So if I distribute the 1, I get 2x squared plus 3x minus 5. If I multiply this guy out, I get 4x squared. The outer and inner terms are 3x and 4x, so I get positive 7x. And the last times the last is positive 3. So basically I FOILed that, but I skipped one step there. Then I'm going to clean it up and combine my like terms. So I will have a total of 6x squared plus 10x minus 2. Okay, so it's looking a little better, but that one does have a common factor of 2. We'll take a 2 out, and that'll leave us with 3x squared plus 5x minus 1. And we could try to factor that again, but I think we'll see that nothing's going to multiply to negative 3 but add to 5, right? So we're done. So there's our answer. And so that's a pretty good introduction to the product rule.